Right, so moving on, question number 35. A binary liquid mixture prepared by mixing two liquids in a closed, rigid, evacuated container at a given temperature shows negative deviation. So I would like to draw the phase diagram initially. Give me a second again. So let's say you have a container. Here there is A, here there is B. And I would write P naught A is greater than P naught B. Okay, so I will try to draw the vapor pressure composition phase diagram for this. So let's take P naught A is greater than P naught B. So here I will show P naught A, and here I would show P naught B. Right. So my phase diagram would be straight line like this, straight line like this, and this is the total pressure straight line, PA plus PB. So P naught A is here. So here XA will be 1. XB would be 0. This is XA, okay? And here XA will be 0. Here XB would be 1. So here you should write down here composition. Here you should write down pressure, let's say in ATM. All these should be marked, okay? So here this is PA equal XA, P naught A XA, and here PB, P naught B XP, and here PA plus PB, total pressure. So this is the normal ideal equation. Now here it says, it shows a negative deviation. So if you remember, in this particular solution, the intermolecular force between AA, BB, or even AB, all are equal, right? That is why this forms an ideal solution. So when you mix this ideal solution, similar number of bonds are broken and similar number of bonds are formed. So there is no change in volume, or either typically no change in enthalpy as well. Okay, because if 100 kilojoule is taken for breaking the bonds, 100 kilojoule is formed for breaking the forming the bonds, because all these bond strengths are equal, right? For this particular case, the ideal condition. But here they are say it is a negative deviation. So in a negative deviation, you know, this vapor pressure is little bit lower than the actual ideal gas situation, except very close to the absolute composition. So, okay. So this is what a negative deviation curve looks like. So why it is a negative deviation? Because at this case, the interaction between AB molecules are greater than the actual AA molecules or BB molecules. Okay, so this is the situation. Which makes this solution harder for evaporate. Okay, because AB molecules are now tightly packed than AA remaining alone itself or BB remaining alone itself in the solution. So initially AA nicely escaped from the system, BB nicely escaped from the system. But when you mix, now AB has a higher strong bond than AA or BB. So now escaping is a little bit difficult than the ideal case. That is why it shows a negative deviation. So in negative deviation, sorry, here the bond forming strength is higher than the bond breaking strength. For an example, if you give 100 kilojoule to break this bond, when AB forms its new bond, it releases more energy. Therefore, here, this delta H is negative, right? Because forming strength is higher than breaking strength. If you give 100 kilojoule to break, when AB forms, it will release like minus 120. So there is a net minus 20 enthalpy, right? And when you consider about the volume, now the volume is now lower than the volume of an ideal solution, because when the bond is strong, the bond gets strong between A and B, the molecules are closer to each other than in an ideal case, so that the interactions are strong, so the volume get decreased. Okay, so that is the idea of a negative deviation. For a positive deviation, you should think all would be reverse. Okay, delta H would be positive and volume will be positive. Right. Let's go to the statement. The total vapor pressure of the mixture is less than the expected total vapor pressure should be behave as an ideal mixture. So you see here, for a certain composition, if I take this composition, you see here, this is the ideal total vapor pressure. This is the vapor pressure of a negative deviation. You see here, it is lower. So this statement is correct. Heat is released when the mixture is formed. What do you think? So I have explained to you. This bonding is stronger than the breaking, so heat is going to given out. So delta H is negative. So this is also correct. That is what I have explained here for the negative deviation, deviated solution. The number of molecules in the vapor phase of the mixture is greater than the expected. So if the vapor pressure, the number of molecules in the vapor phase is greater. If it is greater, then the vapor pressure should be greater. No, the vapor pressure is lower. So it is not greater, it is lower. This statement is wrong. Heat is absorbed. Heat is not absorbed. Heat is given out. So AB is correct. The answer is 1. You understand how we can tackle this type of question, right? So let's move on.